Now we're going to work on inequalities. I'm going to give you a few different rules for inequalities. In general, inequalities are very similar to equations where there's an equal sign. Just a little bit of difference. Now we're going to talk about inequalities. Inequalities are when we have greater than or equal. Greater than or equal. When would I use, what's the difference? When do I use one and not the other? Let's say, for example, I have 2 is greater than 2. Is that a true statement? No, this is false. 2 is not greater than 2. 2 is equal to 2. Now, that means if I put that little underline there, which is my equal sign, now this becomes true. All that really we're worried about is the end point. Because here, if I were to graph this on a number line, here's 0, 1, 2. X is greater than 2. I would say we have an open circle because I can't include 2, but I don't know what the closest number to 2 is. Because if you say, well, it's 2.1, I say, well, what about 2.01? And then you say, okay, 2.01. I say, well, what about 2.001? And we could do that forever because there is no closest point. We're saying whatever the closest point is, that's where we're starting, which is right after 2. So it's 2, but not including the number 2. And then if I'm looking for greater than, the numbers going to the right here are all greater than 2. And here's 3. All these values are what I'm looking for my x. If I have a number line, same, 0, 1, 2, 3, and I want to know what x is greater than or equal to 2 looks like. Well, now I'm including 2 because it can be equal to 2, so I close that dot and everything else stays the same. All I'm really worried about is that endpoint, where we start. I also have less than or less than or equal. And I know many of you have been taught different ways. I've heard of alligators and L's and all kinds of things to remember what greater than is and what less than is. My favorite way, just I'll fill you in. If I have a 2 and a 3, well, 2 is smaller than 3. I put the smaller end of my inequality sign toward the 2 and the bigger end toward the 3, which means that's really the same. If I change it, I have to turn this around, and when I'm calling the bigger end is this side. It's open very big. The other side just comes to a point, so it's small. And that's how I remember, that's how I do which way I'm going. Now, let's do this problem. Notice I'm starting at -3. And -3 is the smallest number. From there, it's going to the right, and the numbers are getting bigger and bigger. That means -3 is the smallest, and all my numbers are bigger than -3. Or I can say x is greater than -3. Here I'm saying this says -3 is less than all my values I'm calling x because it tells me to use x. This one says x is greater than -3. Now, the only thing that we have to think about is that's a closed circle. I didn't take into account it's a closed circle yet. I have to make these less than or equal or greater than or equal. That's because I have a closed dot. That closed dot makes me have to put that underline. I can put this answer in either way. Both of these answers are correct. When we solve inequalities, this is the only thing that really changes between equations, which are equal, and inequalities, which are, for this example, equal, or it could be less than or greater than. That's an inequality. There's only one rule. Very important. If I multiply or divide by a negative number, I flip my inequality sign. That's it. If I multiply or divide by a negative number, I flip my inequality sign. Make sure you always, every time you take a step, make sure you always think about that. Let's begin. I start with 20 is less than or equal to c plus 5. If I had an equal sign there, what would I do? I would subtract 5 from both sides and isolate my c. I'm going to do the exact same thing. I'm going to subtract 5. This becomes 15. This becomes c. This is 0. Now I have to figure out which way my inequality sign's going. Did I multiply or divide by a negative number? I did not. I subtracted. This stays the same. My answer is C. 15 is less than or equal to C, or C is greater than or equal to 15. These are exactly the same. I have 63 is greater than or equal to negative 27, O. That's not O. It's not a 0. It's a letter. And we're solving for O. I have multiplication on the right side. Negative 27 times O. What do? I divide both sides by negative 27. The negative 27s cancel. On this side, I get negative 63 divided by 27. On the right-hand side, I get O, and I have to figure out which way my inequality sign is going. Did I multiply or divide by a negative number? Oh, I did. That means I have to flip the sign. It's going to go the other way. I can divide both 63 and 27 by 3. I can divide both 63 and 27 by 9. If I divide 63 by 9, I get 7. If I divide 27 by 9, I get 3. And that's my final answer. Or, as I said before, you can switch the positioning. If you flip the values, you also have to flip the inequality. So either one of these two is my final answer. This one looks a little more complicated. I don't think it is, but we'll do this anyway. I start with negative 11q minus 2 is greater than or equal to negative 5q plus 82. And I solve it exactly the same way I would solve any equation. And I start with, well, I need the q's all on the same side. And I could choose which side I'm going to put the q's on. And I also can choose, do I want in the end for it to be positive or negative? If I take this 5q and I want to move it to this side of the inequality, I'm going to still have a negative number on the left. If I do it the opposite way and I take this negative 11q and I move it to the right, I'm going to get a positive value. That's going to become positive 11q, which is bigger than negative 5q, which means I'm going to add 5q to both sides. And just like I showed you before, I can also add 2 to both sides at the same time. Why do I want to do that? Just skips a step, because negative 2 plus 2 is 0. That's gone. Negative 5q plus 5q is 0. That's gone. And then I just add negative 11q plus 5q, which is negative 6q. On the right, I have 82 plus 2, which is 84. And now I just have to decide my inequality sign. Did I multiply or divide by a negative number? I didn't. I added positive numbers to each side. I didn't multiply or divide anything. And with inequalities, be careful, because I can add the same thing to both sides, but I don't want to add and divide at the same time. So just be careful of that, which means my sign stays exactly the same way. My next step, I'm still trying to find out what q is, so I'm going to isolate q by dividing both sides by negative 6. The negative 6's cancel, and I end up with q on the left. On the right, I have negative 8 divided by 6 is 1. 24 divided by 6 is 4. That means I have negative 14 on the right-hand side. And I always go back to my question. Did I multiply or divide by a negative number? I did. I divided by negative 6, which means I have to flip my inequality, and there's my final answer. All right, this is going to be our final question. We have 7/3 b plus 2 is less than 5/2 plus 1/2. 1/2 b. Again, I'm going to show you a new technique. Whenever I'm adding or subtracting fractions, remember, I always have to find a least common denominator. Notice I have a 3 and a 1 on the left-hand side for my denominators and 2 2's on the right-hand side. But what I want to do is I want to find a least common denominator for all my values. My 3, my 2, and don't worry about 1. Again, these have no factors in common. I can't reduce 3 any, and I can't reduce 2 any. When that happens, I multiply them together, and my least common denominator is 6. Now I'm going to show you a really cool trick. Whenever I have an equality or an inequality, and remember, I want to make things positive when I do this so I don't have to worry about my signs. I can multiply both sides by my least common denominator. Why would I do that? Well, this becomes 6 times 7/3 b plus 6 times 12. I'm distributing. I multiplied by a positive. I don't have to flip my inequality sign. I have 6 times 5 halves plus 6 times 1/2 b. I'm distributing on the right as well. Now, remember I taught you whenever you are multiplying, you want to simplify, then multiply, which means 6 divided by 3 is 2. 6 times 2 is 12. I don't have to do anything there. Now I've eliminated my denominator. On this side, I have 2 times 7, which is 14, times b plus 12. I haven't done anything to both sides. I already did it before. Now I have 6 divided by 2 is 3, which gives me 15. And again, 6 divided by 2 is 3, which gives me plus 3b. Everything else is canceled out except 3 times 1 and b. Now this is simple. Hopefully, I'm going to isolate my b. How am I going to do that? I'm going to subtract 3b from both sides. I'll do this in slower steps this time. I get 11b plus 12 is less than 15. This cancels the 0. I did check for my inequality sign, but I only subtracted. I didn't multiply or divide. I don't have to worry about anything if I don't multiply or divide. Again, I'm going to subtract 12 from both sides, and I get, this is 0. 11b is less than 3. I did not multiply or divide. I don't have to worry about anything. And last, I have 11b is less than 3. I divide both sides by 11. I cancel. I get b is less than 3/11ths. And that is my final answer. Don't worry about how many steps there are. Don't worry about what happened before. Once you get a new line, that new line is the only thing you're looking at. You're always going towards a solution. Never go backwards. And that's really my advice. Thank you for watching.